Hey guys, so here's how the notes are going to work while we're doing it remotely. I'm going to post these videos which will cover a portion of this notes packet that you've been given, and then you'll flip to the back where there are some practice problems, and I'll do a few of those as well. Then I'll post the homework, which is just going to be from the textbook for you to do, and then either turn in the physical sheet of paper to whoever's here in person, or I may have you scan and upload it like you would have done a couple of years ago through remote learning. That's something that I'll have ironed out before we start school. But what this video is going to be is the first day of lesson 1.1. Now this lesson is going to take a few days. So I'm just going to be doing a part of it, and then tomorrow I'll send you the next part of it, and we'll keep going until we finish this lesson. All right, most of it's going to be review, dealing with equations and inequalities. Now what equations are, obviously, as opposed to inequalities, is a situation where you've got an equal sign versus a situation where you might have like a greater than or equal to, or a less than, or something like that, right? So equations, we're going to get a solution, which means that x is a certain value, or a is a certain value. With an inequality, we're going to get a range of values where x is less than something, or x is greater than or equal to some value. So everything that satisfies an inequality will have to be represented a little bit differently than the way we represent the solution to an equation. But all we're doing here is just solving like you would have done over the course of your math careers so far. So let's just take a look at problem number 1. We've got 4 times 2x minus 3, there's a parentheses situation, plus 3 is equal to, so this is an equation, 4x minus 29. Now there are a few different ways that you could approach this. What I'm going to choose to do is not to distribute that 4, but to subtract the 3 from both sides. So I'm going to do that here. That's going to leave me with 4 times 2x minus 3 equals 4x minus 32. If you want to distribute that 4, you definitely can. But what I'm going to do, just to remind you that this is an option, is since 4 is being multiplied by this whole quantity, 2x minus 3, I'm going to divide by 4, canceling the 4's. And that just means I have to divide both of these two things by 4. So that's going to leave me with my 2x minus 3 on this side. I don't need the parentheses anymore. And then on this side, 4x divided by 4 is 1x, and 32 divided by 4 is 8. 2 more steps. I'm just going to go ahead and add 3 to both sides. And why not at the same time subtract x from both sides? Now I'll have a 1x over here and a negative 5 over here. All right, so there's my solution. The only way for this statement to be true is if x is negative 5. Now they're telling me to give the solution set. I don't really need to do anything here other than just say x is negative 5. But if I wanted to show that solution on a number line, which we typically wouldn't do for an equation, I would say here's negative 5 on the number line. My solution is that value. Right? The only reason I'm graphing it is because what we're about to do with an inequality is going to require the graph. So with an equation, I typically wouldn't do this, but with an inequality, we're going to need to do that because our solution is going to be so many possible values. All right, so let's take a look at number 2. Number 2, we've got a negative 2/5 times y minus 3 plus 2, and that all is greater than 14. A couple different ways that we could deal with this. I think that we probably should move that 2 first. That's just going to make life easier if I subtract that 2 from both sides. And now I've got a negative 2/5 times y minus 3 is greater than 12. You may have heard the term clear the fraction in the past with regard to equations or inequalities that involve a fraction. What I don't want is this fraction here that's being multiplied by the y minus 3. So what I'm going to do to fix that is I'm going to multiply this side of my equation by 5. Because negative 2/5 times 5 is just negative 2. I just have to remember to do the same thing to this side. All right, so I'm going to end up with a negative 2 times y minus 3 is greater than 60. 12 times 5 is 60. And now I can just either distribute that negative 2 if that's what you prefer, or do what I did in the last problem and divide by negative 2. Now I have to be very careful here because you may remember that when you divide or multiply by a negative number, the inequality has to switch directions now. So on the left side, I still have y minus 3, but because I've divided by this negative, it now will say less than. Now would be a good time probably to make the note that when you multiply or divide by a negative, the inequality flips. So I've chosen to write that over here in the notes and questions section of my notes. It's just a thing that I'm going to want to not forget moving forward. And so that makes the right side of my inequality say negative 30. All I need to do now is add 3 to both sides, so y is less than negative 27. And this is where we may want to graph this. It's not saying to graph it explicitly, but we will be told to do that in future situations. So I'm just going to do that right now just to show what this would look like if I represented it on a number line. My number line looks like this, and I'm going to want to have my negative 27 on that number line. Now keep in mind that over here we would find negative 26, right, because that's a larger value than negative 27, and over here is where we would find negative 28. We're saying that all of the acceptable values for y have to be less than negative 27, but not equal to. So we're going to say negative 27 is the value that we're starting at, but we're not going to include that value. Over here, we filled in the negative 5 because we wanted to include the value negative 5. Over here, I don't want to include negative 27 because we're only talking about numbers less than negative 27. So this is where I would draw an arrow this way, showing that my solution is all the values less than negative 27, not including negative 27. So this may be a good time to make a note of when to use the open circle and when to use the closed circle. So that's a couple simple enough examples. Now what we're going to do is flip over to the first set of practice problems, the day 1 practice, and complete a few of those. So you're going to want to complete all 6 of these that are under the day 1 practice problems label. I'm only going to do 3 of them here in the video, and it's up to you to do the rest. And then your homework is going to look a lot like these. Many of the problems are going to be similar to this. So I'll pick a couple for us to do right now. I'm going to do, I guess we'll do the first one. And then maybe we will do the third one. And I think we'll do the last one too together. So that means that the other 3 are for you to do on your own time. And I'll post my key to this on the Course Notes Hub. That's where you'll see the solutions to the whole thing. All right. So in number 1, again, we've got a situation where we've got some fractions involved. It's up to you to decide how you'd like to deal with this, but I'm going to use the clear the fraction method again, and we're going to be very careful how we do this. Because when we clear the fraction, we're multiplying by 3 in this case, but we have to make sure that we multiply everything by 3, right? So if I'm going to multiply this by 3, that means I'm also multiplying this by 3, and I'm also multiplying this by 3, right? So I'm going to have 2 times x plus 4/3, because nothing happens inside that parentheses. The times 3 just canceled out that 3 for a denominator there. That's all that we had happen in that situation. And then we have plus 3x equals 6. So that's all that multiplying by the 3 really did for us. So this is maybe a situation where distributing might make more sense, depending on what your preference is. What I'm going to do here is now distribute that 2, because I'm going to have to deal with that 4/3 at some point. So if I distribute the 2, I now have a 2x plus 2 times 4 is 8, so I'm going to have 8/3, and I still have that plus 3x hanging out over there. Now is probably a good time to combine like terms. So I have 5x plus 8/3 equals 6. Up to you what you'd like to do here, but I have another fraction, so maybe I want to try to clear it. If I do decide to try to clear it, that means I'm multiplying everything again by 3. So that's going to leave me with a 15x plus 8 equals 18. This isn't such a bad situation. I can subtract 8 from both sides and then divide by 15. All right, so 10/15. We wouldn't want to leave our answer that way. We want to always reduce any improper or any fraction at all as much as we possibly could, but we do want to leave it as an improper fraction. 10/15 reduces to 2/3. So that's my final answer here. They're saying to display the solution set using a number line. So if we want to do that here, it's an equation, so it's pretty straightforward. We could just draw a number line, put 2/3 on there, and that's our solution, right? Inequalities are a little bit more involved when we graph the solution, but in an equation, we're just plotting a point at that spot on a number line. Let's take a look at the third example here. I would probably subtract 7 from both sides first, so I have negative 6m is less than or equal to 22. Now I need to divide by a negative value. That's going to flip the inequality, and we have a negative 22/6. Pretty ugly. We should reduce that to negative 11/3. So that's my solution. M is greater than or equal to negative 11/3, but we do need to graph that solution. So I'm going to draw a number line. I'm going to put a negative 11/3 on it. It says greater than or equal to, so I can fill in the point at negative 11/3. And if M is greater than or equal to negative 11/3, that means these are all the values that represent my solutions. So any number greater than or equal to negative 11/3 would satisfy this original inequality. And finally, let's take a look at the sixth example. So we've got 24 minus 2 times 6 minus 2x. Up to you if you want to distribute. This is maybe a situation where you would, because you've got also some parentheses on the right side. So maybe by distributing, that'll make this whole inequality look a little easier. So I'll leave the 24 alone. This becomes a minus 12. This becomes a plus 4x. Just be careful, that's a negative 2 times negative 2x. So that's a positive 4x now. Is less than 4x minus 4. Combining like terms probably makes a lot of sense, at least on the left side. And now we can try to get like terms together. So depending on what you want to do here, maybe you want to subtract 4x from both sides. So let's say I try to do that. We're going to end up with 12 is less than, and my x's are gone. We have not made any mistakes here. The problem is this can never be true. 12 is never less than negative 4. And again, we didn't make any mistakes, so the question is, what does that mean for our solutions to the original inequality? Well, what that means is there's no possible solution to that original inequality because this is never true. So if your final solution can never possibly be true, then the original inequality can never be true. There's no value that you could pick to plug in for x that would make that original inequality true. So no solution. Now, if you got something like, let's say you got a different value from this, and you ended up getting a statement that said 5 is greater than 2 or something like that, well, that is true. And in fact, that's always true. So in that situation, your solution would be all of the real numbers. And that's a symbol just meaning all real numbers, or in other words, infinitely many solutions. There's no value that you could pick that would make that statement not true. All right, so make sure you complete the textbook homework that goes along with this. I'll send instructions for how to turn that in, and the next video will be part 2 of the same lesson.